Good morning. Welcome back to the classroom. What I'm going to do in this video is go through the demonstrations we've already done related to fluid pressure, specifically air pressure, starting with our phenomena, the fire tornado. Remember, we're not explaining the tornado just yet. We're going to do the other demonstrations, see how they relate to changes in heat energy, the volume of a contained space or a volume of gas, and the number of particles in a contained space. Once we recap all those, we'll explain the fire tornado in terms of heat, volume, and particle number. All right, let's get started.
In the recycle bin pressure demonstration, we have two recycle bins placed together. When separated, air gets in between the two recycle bins, allowing pressure to equalize, thus no force. But by placing a bag around the outside, when the bins are pulled apart, the volume in between them increases without any air getting in, dropping the pressure, creating a force squeezing them together, an increase in volume with no particle increase. In our the pressure demonstration, we are modeling something you and I feel all the time as we change elevation, whether it's going up or down a hill or maybe taking a flight. When your elevation increases, the number of air particles around you decrease, creating lower pressure. The pressure inside your head pushes out on your eardrum, making it feel kind of painful. You and I want to yawn or chew or anything to pop our ears. What's happening inside the bell jar is Fred is having all the air removed from outside the balloon. Pressure on the outside of the balloon decreases because there are fewer air particles, while pressure on the inside remains the same, but that difference in pressure causes a force pushing out of the balloon, making the balloon inflate. And this is exactly the kind of thing that would make our heads hurt. Now if we were to change it and allow air back into that bell jar, the pressure will balance again, and Fred's head will shrink. When the pressure is balanced, the force is equal. In our final demonstration, wow, that's some heavy news, I'm simply attempting to lift up a single sheet of newspaper with a stick. I'll flatten the newspaper out on top of the stick, forcing as much air out from underneath the paper as possible, making it nice and smooth. When I push down, the volume underneath the paper is going to increase. But because the increase in volume happens fast and the paper is smooth, not much air is able to get underneath the paper, which means we increase volume without increasing the number of air particles, which means we decrease the pressure. Low pressure underneath the paper and high pressure above the paper creates an unbalanced force pushing down on the newspaper, allowing the stick to break instead of simply lifting up